there are two limits we need to know in order to be able to use the limit definition of derivative to find the derivatives of sine and cosine. In the last two videos, we worked this out. We actually only worked it out halfway. We proved that the limit as x goes to 0 from the right of sine x over x was 1. And I simply told you that the argument could be modified to show that the limit from the left was the same, so that the two-sided limit is 1. Again, you're responsible for knowing that result. You're also responsible for being able to ask questions about the derivation of that result, but I wouldn't expect you to repeat the entire derivation on your own. I would just ask you questions about individual parts. The other limit that we're going to need is this one. So that's what we're going to work out in this video. And what's nice is we're going to be able to use this result. So we're looking at the limit as x goes to 0 of 1 minus cosine x over x. And it may not seem obvious that we can use this result because I see cosines instead of sines. But we're going to use a very nifty trick. We're going to multiply by 1 in the form of something useful over something useful. And what's going to be useful is these same two terms, 1 and cosine, but connected with the opposite sign. So we're going to multiply by 1 plus cosine x over itself. Now, not immediately obvious why we're going to do that, but pay attention to what happens, because this is a very useful trick that you're going to want to keep in your bag of tricks for simplifying things. All right, if I FOIL out the top, the first terms give me 1. The outsides give me cosine x and the insides give me minus cosine x. So those are going to cancel. Now I'm going to just write those in just so we don't forget that we are actually FOILing this out. My last terms are going to give me minus cosine squared x. And then this is over x times 1 plus cosine x. I'm not going to do the multiplication on the bottom. I'm just going to keep that x separate. I was doing the multiplication on the top because I wanted to simplify things. Now, instead of having just a single factor of cosine, I've got a cosine squared. So on top we've got 1 minus cosine squared x over x times 1 plus cosine x. When I have an even power of trig function, I have a Pythagorean identity that will allow me to rewrite that in terms of an even power of a different trig function. I know that sine squared x plus cosine squared x is 1. That's my basic Pythagorean identity. What that means is that sine squared x is the same as 1 minus cosine squared x. So I can write this as the limit as x goes to 0 of sine squared x over x times 1 plus cosine x. Nice. Now, I'm going to just write that sine squared on top as actually two factors of sine x. So that's just sine x times sine x over x times 1 plus cosine of x. So I have two factors on top and two factors on bottom. Now what I'm going to do, and I'll bump up to this top part of the board for this, I'm just going to pair them up. One factor from the top with one factor from the bottom. So I'm going to say this is equal to the limit as x goes to 0 of sine x over x times sine x over 1 plus cosine x. So I'm taking the limit of this entire product. Okay. Notice that's still two factors of sine on top and an x and a 1 plus cosine x on bottom. Okay. Now I'm going to use the product rule for limits and say this is the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of sine x over 1 plus cosine x. I know this limit. That's 1. This limit I can evaluate by plugging in 0 for x, because this function is continuous at 0. I'm going to get sine of 0 over 1 plus cosine of 0. So this is 1, that's that first factor, times sine of 0 is 0, over 1 plus cosine of 0 is 1. But 1 times 0 is just 0. So this limit is 0. Now, this derivation, you are responsible for. This was a lot faster than this derivation. This derivation I want you to study and be able to answer short answer questions about. This one you should know how to do. Okay, so do make sure that you study that derivation.